Welcome to Understand the Math. In this problem, we're given a set H, and we're asked to determine if H is a subspace of R2. There's 3 steps that we can follow to determine if a set is a subspace. The first step is to check that the set contains the 0 vector. The second step is to test for closure under addition. And then the last step is to test for closure under scalar multiplication. I always begin these problems by letting any vector in the set be equal to x and then writing down what x is equal to. According to our h up above in our problem, our vector x is the vector x1 to x2, where x2 is equal to x1. Let's go ahead and plug that in. So we get that vector x is equal to x1. And then for x2, we're going to plug in that x2 is x1, so we get a 2x1. So any vector in our set is in this form. Let's begin by checking that our set H contains the 0 vector. So we're going to check if our vector x is equal to 0. Looking at this form of our vector x, we can see that vector x is going to be equal to the 0 vector if x1 is equal to 0. So if we plug in x1 is equal to 0, we get that x is equal to 0, 0, which is the 0 vector. So let's write down that our set H contains the 0 vector. Now let's go ahead and let's see if our set is closed under addition. To do this, what we're going to do is we're going to create 2 vectors that are just like vector x. I'm going to call the first vector u, and I'm going to let it be equal to u1 to u1. Let me go ahead and highlight this up here so you can see that this is our vector that is any vector in our set H. And then let's call our second vector v, and we're going to make it look just like H, except instead of an x, we're going to have a v. So we have a v1 and a 2v1. To check if it's closed under addition, what we're going to do is we're going to take vector u and we're going to add vector v. So this is going to be if we add the first component, u1 plus v1, and then the second component is 2u1 plus 2v1. And then I'm going to go ahead and rewrite this as u1 plus v1, and then 2 times u1 plus v1. Now what we have to do is we have to see if this vector looks like our vector x that I highlighted above in green. And you can see that if we were to set x1 equal to u1 plus v1, these 2 vectors will be exactly the same. So this tells us that our set H is closed under addition. Now let's go ahead and let's check our third condition. Our third condition is that we have to check for closure under scalar multiplication. This one's actually easier than checking for closure under addition. All we have to do for this one is we're going to take a scalar c and we're going to multiply it by our vector u that we created in step 2. So this becomes c times u1 and then c times 2u1. I'm going to go ahead and rewrite this. The first component stays the same, and then I'm going to write the second component as 2 times c u1. Then what I'm going to do is I'm going to set x1 equal to cu1 and look back up to our vector highlighted in green and see if it's the same. And it definitely is. So that tells us that our set H is closed under scalar multiplication. Because our set H contains the zero vector, because it's closed under addition, and because it's closed under scalar multiplication, we can conclude that H is a subspace of R2.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.